So here's a method for measuring a reflex angle. And this works either in a graphs or a geometry page. I am doing this on a geometry page. And it begins by graphing a circle. So I'm just going to do any circle. And one of the things I'm going to need about this circle is its radius. So I'll measure its radius. Just to check to make sure that looks reasonable. Yes. So this is the radius. Let's remember that. Now we need 2 rays for our angle, if this is the way you are deciding to indicate your angle with rays. Now what this method involves is graphing an arc or constructing an arc between these 2 points. That way when it goes past the pi radians or the 180 degrees, the arc measure still increases, and we can use the relationship between the arc measure and the radius of the circle to determine the angle. Now if I just go ahead and construct an arc, I need 3 points. Now this point I can put in the middle, but the problem is this arc is growing and growing and growing, but once I come back to the beginning again, it's still measuring a huge arc. Notice where the arc is at this point, and I want it to measure a small angle. So this point needs to be very close to my initial arm. What I do to ensure that is the following. I'm just going to get rid of this arc to begin with. I put a very small circle at the point of the initial arm. Let's just give it a radius of 1 for now, because I will make that much shorter later. I can now construct my arc using the intersection point, which I'd better define first. Don't need that one. So here's my arc. I don't need this point anymore, so I can hide it. I don't need this circle anymore, so I can hide it. But one of the things that I will do, actually, after I hide it, is change this to a very small number. And that way, that second point that is used to construct the arc is very close to this one. And so I will always have a fairly good representation of the angle. Now the arc measure is this. So notice as I go around, that measure gets bigger and bigger and bigger. Now we know that the arc length is equal to the radius times the angle. We want to find the angle, so to find the angle we just need to divide the arc length by the radius, and this will give us our answer in radians. So I create this formula, calculate it, select A for the arc length, R for the radius, and this result is now my measure in radians of the central angle. Notice that right around 180 there, it's at 3.14, close to the end there, 6.28, so we know we've got it done fairly well. So all that's left to do is to hide a few things. Of course, if you wanted to convert that to degrees, we could have embedded that conversion formula within our A over R. So I'm just going to now hide what I don't need. Don't actually even need the arc to be showing. If I'm just showing an angle, I don't actually have to need the circle to be showing either. On second thought, I am going to show the arc, just because it helps to see which angle is being represented. And there we go.